Hello students, and let us continue our chapter 1 from 8th grade, IGCSE, and this is from the book Police that I am discussing some of the questions. Okay, so now today I was thinking of doing exercise 2 from chapter 1 from this book Collins. Okay, so exercise 2, these are the questions you can see over here, right? These are the questions, right? So these are the questions that we are going to start answering today. Okay. Now, question number 1, you can see it says that here is a list of numbers, and the numbers you can see are uh, minus 7.2. Okay. Then root 8, root of minus 21. Sorry, minus 21, not root of minus 21. Minus 21, 13 upon 7, and minus root of 4. So these are the numbers. Okay. So I hope there is some overlapping over here, written over here, A, B, C, D. So, in fact, these are the answers written on the screen, okay, in the textbook itself. Okay, so anyway, I'm going to explain you these answers. Okay, so the numbers are minus 7.2, root 8, minus 21, 13 upon 11, and minus root of 4. These are the numbers. Okay, and you this list of numbers you have to write down uh, a number. You have to basically classify these numbers into A, both rational and an integer, okay, B, rational but not an integer, and C, irrational. Okay, so accordingly you will have to put the numbers into this A, B, and C category. Okay, so let us start discussing first. Now first number is minus 7.2, as you can see. Okay, this is that right. One second. Yeah, this is minus 7.2, the first number. Okay. Now, if you go by this minus 7.2, then minus 7.2 is not an integer. That is very clear. Okay. And it is a rational number. Yes, it is a rational number because it is terminating fraction 7.2. That's it. Negative sign. Okay. So this particular number minus 7.2 will come in a category of rational number but not integer. So can you see rational number but not integer is this B, right? So in the B category, I have put this minus 7.2, right? Next one is root of 8, isn't it? Root of 8. Now root of 8 by definition under the square root sign, if you have a perfect square, then it is a rational number. But if under square root sign, if you have a non-perfect number, non-perfect square number, then it is irrational number. So root 8 will be coming in irrational number category. So can you see C is irrational? So root 8 I have put in irrational. Okay. That is root 8 in C category. C is irrational. Okay. Next number is minus 21. Now minus 21 is an integer, and you know all integers are rational also. So minus 21 is a rational number also as well as integer. So we can put it in this category, both rational and an integer. Okay. So minus 21, you can see I have put it in this A category. That is rational as well as integer. Right? This is done. Next is 13 upon 11. Okay. Now 13 upon 11 by definition, it is a fraction and the denominator is non-zero. So it is a rational number. Okay. So one thing is clear, 13 upon 11 is a rational number. But then, is it an integer? No, it is not an integer because 13 upon 11 will give you some number with a decimal point. Okay, so it is not an integer. So it will come into a category of rational but not integer. So in B category, I'll have to put this 13 upon 11. Can you see I've put it in the B category? Okay, 13 upon 11. And there's one more, that is minus root of 4. Now minus root of 4 is as good as minus 2 because root of 4 is 2 and minus 2 is an integer, right? And all integers are rational also. So minus root of 4 will be integer as well as rational, right? So I have put it in this category A, that is minus root of 4 is integer as well as rational. So all these numbers in the list I have put in proper categories. Okay, that was answer number 1. Now let us go to question number 2. Here is a list of numbers again. The numbers are -5, 22 upon 7, root 12, 14.75, root 81, and the last one is 0.3 with a dot on that 3. Okay, so it's a recurring decimal or recurring fraction. Okay. Now what you have to do about these numbers? Sort the numbers into rational and irrational numbers. So just you have to classify them into rational and irrational. Okay, fine. So -5, it will be rational. Okay, so here only I'll write the answer. -5 because it is an integer and all integers are rational. So this will be rational. Okay. 22 upon 7, it's a fraction with a denominator which is non-zero. Again, this is also rational. Root of 12 under the square root sign, if you have a non-perfect square, 12 is a non-perfect square, okay, then it will be irrational. So this will be irrational. 14.75 is a terminating fraction. It is a terminating fraction or terminating decimal, and terminating decimals are nothing but rational. So this 14.75 is rational. Next is root of 81. Root of 81 will get reduced to 9. 9 is an integer and all integers are rational number. So this will be rational. And 0.3 with a dot on that 3 is telling you that 0.3 is a recurring decimal and recurring decimals are always rational. So this is also rational, isn't it? So the numbers are classified. Only one is irrational, other all are rational numbers. Okay, so that is the answer to question number 2. And I have written the answers over here. Can you see here? Okay, so -5 irrational, 22 -5 rational, 22 upon 7 rational, root 12 is irrational, and 14.75 is rational, root 81 is rational, and 0.3 with a dot on it is also rational. Okay, the same thing I have written here also and here also, right? Okay, let us move on to question number 3. So 1 is done, 2 is done. Now question number 3. Sort the numbers into rational and irrational numbers. Once again, you have to sort the numbers into rational and irrational numbers. This time the numbers are root 4, root 5, root 6, root 7, root 8, and root 9. Okay. Now root 4, you know, under a square root sign, if you have a perfect square, then it is rational. Now 4 is a perfect square. Okay. So it is a rational number. So this will be rational. Now root of 5. Now 5 is an non-perfect square. So this will be irrational. This will be also irrational because 6 is also a non-perfect square. 7 is also non-perfect square under square root sign. 8 is also non-perfect square. 9 is a perfect square. So this will be rational. Even otherwise, you know, root 4 will work out to or will reduce to 2, which is an integer, and all integers are rational. Therefore, root 4 is rational. Same way, root 9 will get reduced to 3. Root 9 will get reduced to 3, and 3 is an integer. Okay, so all integers are rational number. So root 4 and root 9, the first and the last are rational, and rest of the middle numbers, you know, that is root 5, root 6, root 7, and root 8, all are irrational because under the square root sign, you have the numbers which are non-perfect square. Okay, so that's the answer for question number 3. So let us check the answers over here for question number 3. So this is the answer for 3. Okay. Now can you see root 4 and root 9, the first and the last one, this I have put into rational category. Okay. And the remaining middle ones, that is root 5, root 6, root 7, and root 8, these are irrational. Okay. So this is the answer to question number 3. Okay. Now question number 4 is this one. Okay. Give an example where A, the product of two irrational numbers is a rational number. Okay. B, okay, first let us give an example of this. The product of two rational numbers is a the product of two irrational numbers is a rational number. So you have to give the example of this. So the example of this is over here. Now this is your answer for. So A is irrational multiplied by irrational, product of two irrational numbers should be rational. Okay, this is the statement. So according to this statement, you can think of root 6 and root 6 because root 6 and root 6 both are irrational numbers. And when you multiply them out, you will get root 36. and root 36 is rational number because root 36 will get reduced to 6, which is an integer as well as rational number. So this example is one that you can give. Second example you can give is root 3 times root 12. Now root 3 is an irrational number because 3 is not a perfect square. Root 12 is also irrational number because 12 is not an perfect square, and both these 3 and 12 non-perfect square numbers are put under the square root sign. So they are irrational. So this is also irrational, this is also irrational. And when you do the product of these two, it will be root 3 into root 12 will be root 36. But this root 36 is rational, isn't it? Root 36 is rational. So this is also another example. I have given two examples, but the question has asked you to answer give only one example. Okay, but I have given two examples purposely. Okay, so that was A. B is what? You have to give an example of rational number multiplied by another rational number giving you a rational number. Okay, so the product of two rational numbers giving you rational. So there are so many examples of this. -5 is an integer, so it is rational number. 6 is an integer, so it is rational number. When you do the product of these two, you get -30, which is again a rational number. Okay. Root 4 is a rational number. 5 is a rational number. When you multiply these two, you get 5 root 4, which is also a rational number. Now 5 root 4 is a rational number. Why? Because 5 root 4 will be 5 multiplied by root 4 is 2. And 5 into 2 is 10. 10 is an integer and all integers are rational number. So this is also rational. Okay. And C is, you have to give an example of rational number multiplied by an irrational number giving you irrational number. Okay. So let us take -5. -5 is an integer, so it is a rational number. Multiplied by root 6. Root 6 is an irrational number, you know why. And when you multiply these two, you'll get -5 root 6, and -5 root 6 is irrational number. So this is an example of rational multiplied by irrational number giving you a irrational number. Okay. So this was answer to question number 4. Now let us see what question number 5 says. Now 4, this is question number 5. Okay, 4 you start. Decide whether each of the statement is true or false. If it is true, give an example. So if the statement is true, you have to give the example. Okay, so let us start from A. A is an integer can be an irrational number. An integer can be an irrational number. Now this is a false statement because every now I have been keeping on telling you that all integers are rational numbers. So there's no way that you can say that an integer can be an irrational number. No. All integers are necessarily rational numbers. So this integer is any one integer which is an irrational number, you will not be able to find out. So this statement is totally false, and because it is false, no need of giving an example. B is an irrational number can be negative. Yeah, so irrational number can be negative is a true statement. So irrational number can be positive as well as negative. So answer for 5th question, A is false. For B, the answer is true because there are many irrational numbers, like pi is an irrational number. If you put a negative side, it will be negative irrational number. Okay. Root 6 is an irrational number. If you put a negative sign in front of it, it will be negative irrational number. Okay. Minus root pi is again negative irrational number. So negative irrational numbers are always possible. Okay, so irrational number can be positive as well as negative. So B is true statement. Let us see what is C. The C statement is the square root of a natural number can be a natural number. The square root of a natural number can be a natural number. Yeah, this is a true statement. Square root of a natural number can be a natural number. It is a true statement. Okay. You take for example this C is true. Example root 4. Okay. So under the square root sign you have 4. So this is square root of a natural number. So square root of a natural number is 2, which is a natural number. Square root of 16 is 4, which is also natural number. But here you have to be careful. This is I think square root of a natural number can square root of a natural number can be which one we are doing? Yeah, C, no? The square root of a natural number can be a natural number. Okay, and the answer written is true. Okay, But what I think is the answer should not be true. I'll tell you why. Uh, this one, okay, C. The square root of natural number, now square root of 4 will be plus 2 as well as minus 2. Okay, there will be both the answers. Square root of 4 will be plus 2 as well as minus 2. I'll tell you why. Plus 2 multiplied by plus 2 will give you 4, and minus 2 multiplied by minus 2 will also give you 4. So this means that root of 4, square root of 4 can be plus 2 also and minus 2 also. Okay. So actually square root of a natural number can be plus 2 as well as minus 2. And if it is minus 2, then minus 2 is not a natural number, isn't it? So this statement C will be false. According to me, it should be false. Okay. Right? And since it is false, you need not give any example. Okay. See, I tried to give the example as root 4 is equal to 2, but I know very well root 4 can be minus 2 as well. Okay. So if it is minus 2, then minus 2 is not a natural number. Okay. So see, this is all depending. So if you consider natural number as 1, 2, 3, 4, 5, then these are this statement is correct. Okay, what I have written. Okay, this false statement is correct. But nowadays, what is happening? Natural numbers are the negative natural. There's something called negative natural numbers also. This is a concept: positive natural number, negative natural number. So 1, 2, 3, 4, etc. are positive natural number, and this minus 1, minus 2, minus 3 are taken as negative natural numbers. Okay. So if you are in the position, or if your teachers, in your school or wherever, okay, if they have told you about this, and if this is allowed, and this is the thing that is acceptable, okay, because when you go in higher class, this will be accepted, okay. But I think in the 7th grade, you must have studied natural numbers as 1, 2, 3, 4 only. I don't think you will be considering minus 1, minus 2, minus 3 as natural numbers, okay. But when you go in higher classes, 1, 2, 3, 4 are treated as positive natural number, and minus 1, minus 2, minus 3 are treated as negative natural number. So whether it is positive or negative natural numbers, but still they are natural numbers. So that way, this particular statement can be true. So this is a question whose answer is a little bit ambiguous. Okay. So if you go by my logic, it will be false. Okay. And if you go by other logic, it can be true also. So that depends. Okay. So this you will have to keep it as it is, this answer. Okay. It depends. So we can always discuss with your school teachers, right? Next question is D, and D says this statement is the square root of a natural number can be a negative integer. Okay, and here also actually the answer negative integer. Okay, so here also the answer should be true, because square root of a natural number, as I told you, can be positive as well as negative integer. Okay, but here the answer written is false. I think this false is written because, as I told you, in some grades or in some schools, I think you have been taught only 1, 2, 3, 4 as natural numbers, not minus 1, minus 2, minus 3 as natural numbers. Okay. Anyways, and another thing, square root of a number 4 is plus 2 as well as minus 2. If you are accepting this, then your answers will be what I am telling you right now. Okay. So this statement will also be D1, root 4 is equal to minus 2, root 6 is equal to minus. As I told you, if you accept this, root 4 can be plus 2 as well as minus 2. If it is minus 2, it is a negative integer. So this statement will be true by that logic, isn't it? So if you accept this logic, then your answer for C will be false, and for D it will be true. I hope you are getting it. Okay. Next question is E, and the E statement is the square root of a natural number can be a rational number. Now this is a true statement. Okay, D is a true statement, right? So square root of a natural number can be a rational number. See, square root of 4 can be plus 2 as well as minus 2. So plus 2 is also integer, minus 2 is also integer, and all integers are rational number. So basically, if it is plus 2, then also it is rational number, minus 2 also it is rational number. So basically, root of 4 is a rational number. Okay, but if you take root of 3, okay, see, if you take root of 4, root of 16, they will be rational. But if you take root of 3, this will be irrational number, isn't it? This will be irrational number. So what is the question saying is D, the square root of a natural number can be rational number. Okay, so this is not true. It is false. You know why false? Because it can be okay. Square root of a natural number can be rational number. Okay, he's saying can be rational number. Okay, so he's not saying that always it should be rational number. So it is true. Okay, so if you take square root of 4, 16, and all those numbers, you know, then definitely this example, square root of 4, square root of 16, then it will be definitely true. Okay, so E is also true. Let us check F. F is the square root of a natural number can be an irrational number. Now this is also true, because as I told you, if you take square root of 8 or square root of 3, okay, as I told you here, square root of 3, or if you take square root of 8, these are irrational numbers, isn't it? But 3 and 8 are natural numbers also. So it is possible that square root of a natural number like 3 and 8 will be irrational. So F is also true. And examples that you can give is root 3, root 2, root 5, root 8. So many examples. Okay? That was question number 5. Now let us move on to question number 6. That is over here. Now question number 6 is use a calculator to find which of the values are rational and which are irrational. Okay. So if you use your calculator now, right now I am not having calculator with me, but without using calculator also I can answer these questions. But I'll tell you, if you use calculator, what will happen. So A is root of 500. Now if you type in root of 500, okay, if you type in root of 500, you will get an answer which will be in okay, let me check it. Okay, because this is whether it is rational or irrational. Okay, see, by the theory, root of 500 will be irrational. Why? Because the 500 is a non-perfect square. 500 is non-perfect square, so it will be irrational, isn't it? Now, still, you know, I'll do one thing. I'll try to find out root of 500 on my calculator, and I'll let you know what answer I'm getting, right? So, root of 500 on my calculator, okay, right here. This is answer 6, okay? So, answer 6, this one we are doing, right? Answer 6, right? Okay, this one. So root of 500 on the calculator, I am getting the value as 22.3607. Okay, I'm getting this value 22.607. Okay, now this he has asked you to use your calculator. Okay, so you are getting a number which is a terminating decimal. Can you see 22.3607? Now this is a terminating fraction, right? So terminating fractions are rational, right? Terminating fractions are rational, so you can treat this as a rational number. Okay, which one? Root of 500. Okay, this one, root of 500 will be rational. Okay, now root of 500, because it works out to a number, it is equivalent to 22.3607. Okay, Therefore, it is a rational number. Okay. So by calculator, if you find out, it will be rational. But by theory, if you go, okay, root of 500, 500, is it a perfect square? No, because 500 can be written as root of 5 into 100. Okay. So this can be written in turn as root of 5 into root of 100. Now root of 100 is 10. So this can be written as 10 root 5. Now 10 root 5, 10 being a rational number, root 5 is an irrational number. So rational number multiplied by an irrational number will be a irrational number. So actually it should be irrational number, or maybe in my calculator 22.3607 is just a limited value given to me. Okay, root of 500. I think it should be 22.3607 and then it should go on. Okay, then it should be irrational, right? So this you will have to check on the calculator. If it is 22.3607 only, this is terminating fraction. Okay, but I don't think that is the case, because root of 500 will be 22.3607 and then it will go on continuing. That means it is non-terminating and non-recurring, and such numbers are irrational. Okay, so you can treat this root 500 as irrational number by theory as well as by calculation. Okay, B is root of 289. Now 289, root of 289 is purely a rational number. Okay, why? Because root of 289, if I type it on the calculator, let me check. Okay, square root of 289, and this I am getting as 17. Okay, so root of 289 works out to 17, and 17 is a rational number, isn't it? So this root of 289, okay, root of 289 is a rational number, right? It is a rational number. Then root of 27. Now 27 is not a perfect square and it is placed under a square root sign. So definitely this root of 27 will be irrational number, isn't it? Let me check this root of 27 on the calculator and let me see what answer I'm getting. Yeah, root of 27 on the calculator. Root of 27 on the calculator. I am showing. I mean the calculator is showing me 5.19615. Okay. Now this cannot be treated as terminating fraction. Okay, because I think it is only up to this 1, 2, 3, 4, 5, 6 digits that it is showing. Okay, there must be a continuation of it. So therefore, this is an irrational number. Okay, so root 27 by theory it should be irrational, and on calculator also root 27 should be 5.19615, and there should be more digits following. Okay, on my calculator I'm using a graphic calculator, TI Inspire CX2. In that they are showing me just 5.19615. Okay, so I cannot treat that as terminating fraction. Okay, next is root of 3 multiplied by root of 12. Now root of 3 is irrational number, root of 12 is also irrational number. So the product of these two will be a rational number. Okay, and this is very straightforward. It will be rational number, because when you work out the product, it will be root of 12 3s are 36, and root of 36 is nothing but 6, which is a rational number. So on calculator, if you do root 3 into root 12, you will get root 36. Okay, let me do that. Square root of 3 times square root of wait. Okay. Okay. So square root of 3 times square root of 13, square root of 12, I am getting square root of 36, which is nothing but 6. So it is rational. Okay. Next is cube root of 729. Now cube root of 729 I am getting as 9 on the calculator. I am getting answer as 9. So it is a rational number. Then this is square root of 361. Square root of 361 is also rational number. Okay. Square root of 361 is also a rational, okay, because 361 is a perfect square. Okay, next is cube root of 25. Now cube root of 25 will be irrational because square root of 25 is 5, but cube root of 25 will be a number which will be non-terminating and non-recurring. So it is a irrational number. Same way, cube root of 1331, if you do on the calculator, if I type this cube root of 1331, okay, so I'm getting the answer as 11, and 11 is a rational number. So this is correct, rational number. And the last question is question number 7. So you have to use these words given in this rectangular bracket, rectangular box, and you have to complete the statement. So the statement is numbers that can be written as fractions are called. Now from here I will take recurring, no, squares, no. Numbers that can be written as fractions. Actually in theory I have taught you all fractions are nothing but rational numbers. So you have to take rational. So this you can pick up and write here, rational. Okay. So numbers that can be written as fractions are called rational numbers. Okay. Then in continuation it says these include dash decimals and dash decimals. Okay. So these rational numbers include recurring decimal as well as terminating decimal. Okay. Recurring as well as terminating. So I've picked up this recurring from here, okay, and terminating from here, okay. Next, numbers that cannot be written as a fraction are called irrational numbers. So numbers which cannot be written as fraction will not be rational, and that the numbers which are not rational will be irrational. So I'll have to pick up this irrational from here and return irrational over here. And the last line says, these includes dash of a number that are not perfect dash. Okay, so this includes square root of the numbers that are not perfect. See, irrational number, one of the definition of irrational number is under the square root sign, if you have a non-perfect square, then those will be irrational. So these numbers means these irrational numbers include square root of numbers that are not perfect squares. So I have to pick up this square root and non-perfect only squares I have to pick up. So this is clear. Can you see all things I have put it? But this natural number I did not find the necessity to put anywhere in this. Okay, so that was something extra given to you. Anyways, so that is question number 7, which we did, and I think that was all in this exercise 2 of the chapter 1 from Collins book. Okay, so today's session I will end here only. Bye.